my LMS, and have you removed the video recordings from lecture 1 to 6?
Yeah, so basically I don't have enough space there, and it asks me to take space off. Like if I want to upload more videos, then I have to take the old ones off.
Okay, makes sense. Thank you.
Had you not downloaded them? Because I think
I
someone.
had downloaded the first 3, but not the 4th and 5th and 6th one. Will you be uploading them anytime soon, or like?
I think someone else requested me this as well. Like someone else told me that they haven't downloaded the lecture.
If you could just like upload them for some time, I could download them and then you can remove them again.
Yeah, in that case, like you'll have to make sure that you've downloaded all the lectures that are there now.
Yes. Yeah.
Because then I don't want to be downloading videos all the
Yes,
time.
I get that.
Because I just presume that you guys they were there for quite some time, so I presume that you've downloaded it. And that's why when it asked me to make some space, I deleted the old videos, but I have them. I can upload them.
Okay, thank you, ma'am.
You're welcome. Okay, does anyone have any question from last week? Have you midterm started already? Why is everyone so there are like very few people here. Otherwise, generally a lot of you just come in.
No, ma'am. No.
Yeah, they haven't. Okay, so just to make sure that you guys are present in the class, Summer will make an announcement in the chat box saying turn on your videos, because I realize that some of you come really late, some of you leave really early. I mean, it's not a problem. I know that you might have other tutorials or lectures going on, but it's all uninformed. So if you guys, if Summer could announce that turn on your videos, and just to make sure that at some point in the lecture she can see where you are, I think that would be great for me, because otherwise I keep worrying whether you are sitting on the other side of screen or not. And then you don't have to turn on your videos all the time. Whenever she announces it or asks you in the chat box, you can just turn it on, and the recording would be speaker mode anyway, so your videos wouldn't be recorded. So she'll just scroll down and see if you're sitting in front of your screen. Does that make sense? Fateh, do you want to say something?
I forgot to mute myself.
Oh, that's fine. That's fine. So we have 1 more minute. If you guys don't have any query, we can jump to the discussion.
Ma'am, about the midterm, it's just the Viva, or it's the written as well as the Viva, or what's the format gonna be?
It's both. It's part written, part discussion, and I think this is going to be the format for both mid and finals, because I generally don't understand. Like, I don't think in any case this is harder medium to assess people. And I already have a lot of problems with the kind of assessments that have taken place when I was a student. I've scored A+ grades in courses where I knew very little, but I took it as a challenge and memorized a lot of things and learned a lot of things and got very good grades, but just to forget them only after a semester. So my main objective for you in this course would be to, think differently, to be able to have learned something new, and to apply it in your day-to-day life. Maybe I just asked you a question about, have you looked at the perfume that you're using? What are the ingredients of those perfume? And is there anything in the ingredients that you should be worried about? And maybe some of you have looked at it, maybe some of you have not. Maybe I just asked you a question about the kind of chemicals that you consume in your day-to-day life for your luxury items or products. So it doesn't have to be the traditional, what is the standard for ozone in troposphere. You don't have to memorize that. I can give you that information and ask you what would happen if the standard were to increase from, let's say, 6 to 8, or what would happen if the DO would come down from 8 to 4. But you have to think about what would go on, and yeah, both the exams would be part viva, part written, and both of them would try and make you think, even if it's during the exams. But of course, most of it would be from the presentations that I've given you. The readings, not so much, because I know some of you don't have time. But the tasks, the class assignments, the written assignments, yes. For example, I could ask you what is an urban heat island. Even though we haven't discussed it, I gave you that task as a take-home task. So I could ask someone in the Viva, not everyone, but maybe someone in the Viva, I could ask them what's the urban heat island, and how has Karachi or Lahore become an urban heat island, and how does the weather impact one, and that impact the weather, like how does it change. I could ask you, even for example, the same thing in the case of Bhopal disaster, that when Bhopal disaster happened, why do you think was that smog or that fog or cloud lying around Bhopal for such a long time? What happened to the weather patterns, and what could have stopped for the wind to not blow the way it should have blown, and why was the Bhopal disaster so extended because of those changes in the atmosphere? You can guess. I mean, if it is an intelligent guess in the Viva, I could still give you good marks. But of course, I will record it for transparency, and it would be there. And it would be you versus you. So I'll see. I know your first assignments. I know your first input. So I think it would be a comparison of what you knew on day one to how you're able to make sense of what you see around, and also from what we've studied. So it's I don't know if this makes sense, but that's the general. You don't have to, so the basic thing is you don't have to memorize everything, but you can't just come without looking at the slides thinking you're too good a reflector and that you're too good for the exams. That can't happen also. So you make sure you've looked at the slides, make sure you've looked at the extra questions, discussions that we've had. Try to make sense of things. For example, an assignment that I'm going to give you today would be about looking at the standards that Pakistan has, comparing it with a standard from a developed world, looking at the gaps, like how have they defined their limits, how have we defined our limits, what's missing in ours, what's present in theirs. Just like very easy and simple, but also something different for you to look at, and not let's memorize each and every limit one by one. It would be just for you to open your minds on what should happen. All right, should we start then? We're already 5 minutes past the lecture. If no one has any other comment, I can take one more question because people are still coming in, and then we can start the presentation. Okay. All right, can you see the presentation?
Yes, miss.
Okay. So we looked at the National Environmental Quality Standards last week. We just looked at them. We didn't get into a detail, but we kind of realized that there are limits for most of the times. We only looked at the air pollutants, the SOx's, NOx's. We discussed that in detail. We touched upon the effluent standards. So standards for discarding water, or dumping water, whether that's municipal wastewater or industrial wastewater. So they have kind of the same limits, which we will discuss later, whether it's a wise choice to put both in one category or to have the same effluent standards for both. But today we will look at them And because we have looked at the air pollutants already, I thought I should start the discussion with a very brief intro on heavy metals, not a very extended introduction of where everything's coming from. We know that heavy metals are present in the air, in the atmosphere, in the lithosphere. We know they come from the rocks, from sediments. We also know that they come from the fossil fuels, the burning of fossil fuels. So their sources are really common, but their limits in the wastewater, or their limits in the, especially for example for lead in both air and effluent standards, is defined. But why do we care so much about these heavy metals? Why is it important for us to decide on a limit, especially if they're already present in certain areas naturally? So we'll try to make sense of that, and then we'll jump back to the air quality standards, because then I'm going to give you a home task for what's happening. Let me pin this and then we can start. So right, why are heavy metals called heavy? It's a very common sense question. Nobody? Yes, Rafi.
Because of their relative atomic mass.
Yeah, so they have higher atomic mass, but more than that, it's their density. Their density is above 6 grams per centimeter cube. And it's there's another slide that I've given at the annex where I've given their density values as well. So they're denser. Like all the other metals, they're malleable, they're soft, they can be turned into certain structures that can be used. They have higher melting and boiling points. They have a lot of isotopes. They have uses in the industry. They have uses in our everyday life. For example, zinc is an essential element. It's an essential metal. We need it in our food, in our diet, to have a healthy growth. But some of them have toxic impacts. But even for these essential elements that we need for proper growth or proper nutrition in our body, their excess of these is also bad. And I think one of the takeaways from this course also would be the fact that almost everything in excess is poison. So I think the same discussion that we've had last week on radiations, that even if it's low radiations, even if it's general, they don't cause any harm. If we have long-term exposure of those, they could cause different things to different organisms. And the amount of toxicity or the amount of impact sometimes also depends, especially if you think about the toxicity studies on gender, on age. So for example, a lot of these heavy metals have impact the children more than the adults, because their bodies are still young, they're still growing. So it's easier for those cells to be damaged easily, quickly, compared to any adult body. And the same could be said for elderly. So the toxicity, the impact of a particular thing would depend on who is being exposed to it and how long are they being exposed to it and how are they taking it in. So is it just a dermal exposure? Is it an exposure of the eye or to the eye? Is it ingestion? So are you taking it in? Are you inhaling it? So for example, if you have smog around you and you know that the particulate matter in there is a toxic gas, let's say it's ozone, and if you inhale it, then you would know that because you've taken it into your body, it's going to impact your health. But let's say you haven't inhaled it, you're wearing a mask, then it will not have that much impact on you. But then there was also a discussion on people who already have asthma, who already have breathing issues, would be impacted by the smog more. So I think all of these toxicities are so relevant to who, where, and how they're hitting someone. So the point of contact, the point of exposure, the age, the dose. I think the dose is really important. So in general, I think the principle for anything in the environment is anything in excess is going to cause you some harm. And you need to, of course, study it to find out what's the scale of the harm that would be caused. But for these toxic metals, there's they're generally found in the in planet Earth. They're quite abundant, but then they make ways into other places. So if they're found in rocks, the weathering via the air, so if the airborne particles can go into the soil where agriculture is being practiced, then they become kind of a part of the agricultural practice as well. And we'll look at this in detail in the coming slides, but a lot of the industrial activities. So when the environment is being mismanaged, for example, if the waste of the industries or if the effluent of the industries finds its way to a site, or let's say a dump site, and the water from that dump site finds its way to a place where crops are being grown, or sometimes even those effluents could be directly used to grow crops, how would that impact the life? Because generally, I think in terms of human exposure, it has been shown that most of the heavy metals that are found in our body come in the form of food that we eat. So we ingest those heavy metals, and they have multiple impacts on our body. For example, zinc, that on the one hand is really essential for our growth. It's a micronutrient. It can cause what's called hemotoxicity or toxicity to the blood. Arsenic can damage the liver. Mercury and lead, they impact your or affect your central nervous system and are neurotoxins. And cadmium can impact your lungs and kidneys. So a lot of these heavy metals have multiple impacts as well, but they also have very targeted impacts in the body. And of course, this depends on where and how they reach your body. So lead is, I think we're so familiar with lead and we see it all around us so often that we hardly ever think it could be so toxic. So unless someone tells us that it's toxic, or unless someone tells us that it has impacts on the health, we would not bother to look that up. We've looked at lead batteries throughout our lives. We've heard of lead sheets, we've heard of lead pipes, we've heard of lead in the wires, but we hardly ever think of the toxic impacts of it. Now, I think that's why the understanding of the applications of these heavy metals, their introduction into our everyday environment, whether it's indoor or outdoor, into the air that we breathe, as well as into the soil where we take our food from, becomes important, because we are in a way extracting it from those rocks, bringing it to the factories, turning into products that we need, making our lives easy. But when it comes to, for example, dumping these into a landfill, then what? Or when it comes to burning them, then what? And how's that going to affect the overall cycle or the environment? Now, because, and there's a reason why I've discussed soil first. Pakistan doesn't have very explicit soil quality standards, I think, and they also don't have a lot of food or drug related standards as well. Even for the environmental standards, because I'm going to give you an assignment, I will not discuss it in a greater detail. You will see that there are very few parameters that have been explained or given emission standards to. For the rest of them, for example, if there are 32 standards regarding the air that have been defined, what about, there are thousands of chemicals around us. What about them? Have we ever created a baseline study on what is present in our air? And only when we know what's present in our air would we be able to then give certain limits. So I think we're just going with the classic pollutants that are present everywhere in the world, and we have given them certain standards based on the global norm. And whether or not we are meeting those standards is another debate. But in the soil, because generally when we discuss this and generally when we think of soil, we don't think so much about the heavy metals. But what happens when heavy metals are present in the soil is that clay generally and the humus, we already said they have this sort of alkaline in nature, and they have negative charges around them. And what happens is that the calcium and magnesium, which have +2 signs, or the hydrogen with a positive sign, it would come and combine or absorb onto the surface of these clay particles. So they form these colloids or these aggregate structures in the soil, which then makes it able to hold water. So remember when we studied soil or the lithosphere, we said that clay or humus has the ability to retain more water compared to desert or sands. So when this happens, then we know that they have the ability, a structure is formed, and because of that structure, there's an ability to hold more water. Yes, Nadia.
Ma'am, I wanted to ask that these metals like calcium, magnesium, and H plus ions are basically they are the I mean, these are the ions that are needed in our body, right? But I wonder, I mean, at what limit? I mean, they become these metal pollutant metals that are causing these that are having this deleterious effect on the environment.
So calcium and magnesium are the minerals that we need in our body, and heavy metals generally refers to those that have higher density or higher atomic mass, as we said, and they are in higher concentrations toxic to the body. And the difference actually is between the background conditions in the environment. So for example, in a place where there are more rocks in the country, we could just go and see what the background concentration is, where there's no human activity, there's no anthropogenic activity, you would just go and see what's the background condition, because there would already be some lead there would already be some zinc or chromium or copper there. And then that background tells us that this is already present in the environment. But the standards have generally been set to the level where we know they're definitely toxic. Now, calcium and magnesium are not toxic. They're generally found in our water, and they're essential for our bones. But they are essential for plant growth as well. What happens when these toxic elements or these heavy metals are present in the soil is that they knock these off, because they also have positive signs. So for example, zinc, chromium, cadmium, they all have positive signs, all valences. And when that +3 or +6 or +2 comes and combines with the clay, it knocks the calcium and magnesium off. And when it does that, it makes that nutrient, it puts it in an unavailable form, as well as a toxic metal, it is now present in your soil. And that can absorb onto the roots, it can absorb onto the structure, or it can even be taken up by the plant if it's in a bioavailable form. So let's say that toxic metal or that heavy metal has combined with something that will be taken up by the plant, then it will become a part of the biomass. But often it's just deposited on the surface and it's just absorbed onto the surface. Mostly it's that.
Oh, ma'am, does it mean that the presence of calcium and magnesium around the clay particles is normal, but when the heavy metals knocks off these metals, then that is something abnormal to our environment?
Yeah. So that this is like naturally a part of the soil that we're talking about, right? And we know that calcium and magnesium are essential nutrients for plant growth, as they are for human growth as well. But so generally what happens is they would go and combine to these clay particles. But if these heavy metals are present, they would do that instead and take these off and now become a part of the soil that was otherwise a healthy soil and did not have any concentration of toxic heavy metals in the soil. But so clay is the basic form. Then we spoke about humus and lignin, in which the organic matter is decaying in the soil and providing all those nutrients to the plants. Those lignin and humus have the ability to react with these chemicals and form fulvic acid or humic acid. So this is with all of these essential nutrients that are present in the soil, right? But and this is the structure for people, for example, from chemistry or bio, who would be interested in knowing what these acids actually look like, because saying their names is easier. But if you look at it, it's like a complex structure on its own. So let's say it reacts with these and then becomes water soluble and insoluble and remains in the soil, then it tends to be less available for the plants that would have otherwise taken up the nutrients. And the presence of heavy metal in the soil, as we said, could be either in its combination with the fulvic acid or the humic acid. So that way, particularly if it makes something insoluble to in water, then it would probably mean that it would make it less available for the plant. And similarly, if it gets absorbed onto the clay, as we said, then again, it's making the clay particle it's changing its properties, and it's becoming a part of this sphere that was otherwise clean and unaware of this foreign agent that could come and change the properties, and change the properties such that it would make the entire food chain toxic. Because if it is absorbed onto the plant, or if it is taken up by the plant, if it's water soluble, and if it's taken up by the plant, then we end up eating it, and when we eat it, we will accumulate it. And we know that the bioaccumulation goes higher. So the higher we go in the food chain, the toxic it would be in our body. And the third way in which it can also react or change forms in the soil is by reacting with phosphates. Okay, now we know that in the soil structure, it is important that clay or the colloids are present. It's important that the humic acid or the fulvic acid is present, so that the lignin and humus can provide the nutrients for the soil. But phosphates are also important. So we studied that phosphates or ammonium is generally like present in the fertilizer, and it's given to the plants. We had connected it with the eutrophication, and that was because of excess fertigation, or putting excess fertilizer into the soil, and then the water washing it off and taking it into a water body and causing eutrophication. But in a normal soil, in a normal lithosphere layer, this phosphate is important for the plant, because the plant needs it to grow up. The growth of plants in the eutrophic lake is also because phosphate is a nutrient. So why are these reactions? These heavy metals, when they're present in the soil, they change the characteristics of the soil. And by changing the characteristics, they become bioavailable themselves and make other nutrients, or turn other nutrients into non-bioavailable form. So how change in a chemical or presence of one chemical changes the entire chemistry in the soil and the basic building blocks of nutrition or of growth in a particular sphere. So I think this was important, because when we actually speak about the NEQs, we would not talk about these, we would not talk about the soil, we would not talk about the lithosphere. And somehow I think this serves as the basis for these toxins to be present in the overall food chain, or in the overall biosphere and atmosphere. And lead, you would find it in the gaseous emissions as well as in the effluent emissions. And of course, they're present both naturally and are sent in by combustion of the fuels and other activities such as smelting. We've studied all of those activities one way or another, so I wouldn't want to get into the details. But there are a lot of products in our day-to-day life, such as, have you heard, so for example, we studied the lead batteries. We also had a lot of lead-based paints. So I know that one faculty from chemistry has been working here to take these heavy metals off the paints, because they've been an essential part of the paints that we've been using. And that's why people like the traditional lime to whiten their walls compared to these fancy paints. Okay, so now, why, like I said, like everything is a drug, everything is toxin if it is exposed to you or is brought to you at a higher dose or over a longer period of time. And there are certain terms for this area of toxicology. So we were in the lithosphere right now, just moments ago, but now we're talking about, let's say, for example, in the form of dust particles, in the form of soot, in the form of ash, or any other form, these heavy metals becoming a part of the air, or in the form of food, becoming a part of the biosphere or the life that would then consume it. And by life, I particularly mean us humans, who stand in the center of everything that's happening on Earth. So we could just come into contact with them with, through dermal or the skin, as well as eyes. So I think this is actually very relevant to the discussion that we could have around COVID or Corona when we discuss microorganisms and their impact on our health. Of how, generally when we speak about aerosols, or when I spoke about suspended particulate matter, we did not speak about biological suspensions, right? We did not speak about bioaerosols. While there is a virus that is lying around us in the form of, in certain droplets that would be suspended in the air as aerosols or as droplets. So those bioaerosols that have impact on our health have impact only if we ingest them or if they contact with our eyes, or the contact or enter our body via our eyes. So there's one form of contact. The other is that the food contains, because it was able to take up heavy metals from the soil or from the environment, or because certain volcanic ash deposited on it, it was able to absorb it, and we did not wash the plant well, and or because it was already a part of the biomass of the plant, we ate it and then we ended up ingesting it. So now it's serious because we have made it a part of our body by eating it in. And the third is inhalation, which is specifically for those that are found in soot, in smoke, in smog, if we inhale it. And the inhalation has like certain levels as well, which I think we will discuss at some point. So when you inhale it, certain things just get caught in your nose because your nose has hair, the tissues there, they generally don't allow for a lot of things to go into your lungs. And they stop. So they act as natural filters. Then some of them just deposit in your throat, some in the bronchioles, and then finally some of them could find their way into your alveoli, in your lungs, and then become a part of your body or the blood circulation. So and also with that, I think is important, when I said that the exposure could be short term or long term, there are terms for it, scientific terms, which is called acute and chronic. So lower concentrations of a toxin over a longer period of time could have as much impact as a very high concentration over a very short period of time. All right, so, and those impacts could vary. Those impacts could be additive, or they could be synergistic. Sorry, I was reading the chats. Or they could be antagonistic. So additive is 1 + 1 is equal to 2. Synergistic would be 1 + 1 is equal to 11. And antagonistic could be 1 + 1 is equal to 0.5. So sometimes these chemicals add and just become double. So both of their impacts add onto each other. Sometimes they multiply the effects that they could cause in your body. And sometimes one could cancel the other. Maybe the presence of zinc could cancel the impact of another. But the way in which they impact your body can vary. And because we're speaking about the environment, lead, mercury, and other, because we have brought them into our day-to-day lives and luxuries, when we throw them out, so whether it's in the form of any gadgets that contain these heavy metals, whether it's in the form of for example, batteries or the sheets that we use in our buildings, or other products, when those solid waste is dumped, when it's discarded, then it becomes a part of our solid waste. And when that solid waste is incinerated, and incineration means burning at a higher temperature and collecting very small amount of waste, that the exhaust as well as the waste that remains could contain these. Where would you throw that then? The waste that's being sent to the landfill could contain these and would become a part of the environment in however way it wants. And the waste that's lying around us in general, or especially, for example, in the form of vehicular exhaust, would just build up around us. But even though we say that the sources are natural, once they become a part of our environment and then we discard them, then we are equally responsible for how the life cycle is moving from one part of the earth to the other part, or one part of the lithosphere to the other part of the lithosphere, where you're taking an ore, or you're taking a metal, or you're taking a heavy metal from somewhere, you're making use of it in one city, you're throwing it at the suburbs somewhere, and then how do you change that cycle? And how do you take that toxin from one place to the other? And how does it, the environment react to that? And the livelihoods or the lives that were around, how do they react to it? Now, we discussed temperature and alkalinity sort of a little bit in the previous lecture, but I think with reference to heavy metals, and this is why understanding one thing and its relationship to the other is important. Last time when we discussed acidity and alkalinity, or in general when we have discussed acidity, we've discussed acid rains, and we've discussed their impact on soil, their impact on our buildings, their impact on water bodies, and therefore the impact on fauna. Last time we also said that if the pH would increase or decrease because of any industrial effluent or because of acid rain or anything else, the life that lives below water would be impacted. And we showed how on a certain pH scale, certain kinds of fish would be able to survive and others won't be able to survive on such scales. And we already know what pH is. I'd explained it somewhere in your NX slides way earlier. But there are very strong acids. So you might have heard about hydrochloric acid, nitric acid, that generally give you the hydronium ion. And there are bases like potassium hydroxide or sodium hydroxide that generally give you the hydroxyl ions. Now, why are they important for the presence of heavy metal in the soil? Because generally, when you look at a soil that is more acidic would have these higher concentrations of the toxic forms of these heavy metals. So one thing that I forgot to mention, and I showed you the table, was the number of isotopes that these heavy metals have. So for example, chromium comes in +3 valency as well as +6. No, just the two examples. There are many isotopes of chromium. Now, +3 is essential to life. We need it in some concentrations in our food chain. But the +6 is highly toxic. And its toxicity and that toxicity would be present at a certain pH. So at a certain pH, one form of heavy metal would be present, and that form of heavy metal would be 10 times or 100 times or 20 times more toxic than the other form. And that's why what happens in the soil in terms of its acidity or alkalinity increasing or decreasing becomes important. And generally, what would we want? When there's acid rain or when there's acidic, let's say, for example, we were talking about mining, and we were saying that mines generally drain out a water which is called acid mine drainage, which is acidic in nature, comes out from the mine as a wastewater, and contains a lot of heavy metals, because we know that heavy metals are present in high concentrations on our rocks or sediments. Now that is rich in heavy metals. So what would you do to that acid mine drainage that comes out of a mine? You would probably put a salt or take it into a buffer zone, or do something with it that will make sure that it's not acidic anymore. Generally, to treat an acid, you put a base in, because the acid and base react with one another to form salt and water. And generally, or there could be other buffers that you would just put. And I've given some examples like calcium carbonate. Although when we studied it with reference to the Taj Mahal, we said that calcium carbonate was also being eroded because of acid rain. But when calcium carbonate is present in the soil, it could give a buffer to the soil to make sure that it's not acidic enough. When acid rain comes, it sort of nullifies its effect. It sort of retains the pH and doesn't make it too acidic for the heavy metals to become more toxic. So there is that relation between acidity and basicity to the toxicity of a heavy metal. And they take place at certain pHs. Just to give you a break, what is the difference between hard water and soft water? Yes, Nadia.
Ma'am, hard water is the water where we cannot make leather, and soft one is where we can make the leather better. So there are these minerals in the hard water that makes it hard, and it makes it difficult to make the leather in it.
Yeah. Okay. So hard water is also the water that contains more calcium and magnesium, or those ions, and it renders it hard. And softer is probably the one with more, let's say, sodium or sodium chloride. And the basic difference is them forming leathers or not forming leathers. And of course, that this also relates to the nutrition of the soil, but this is just for you to have a look at. Something we touched upon last week, and this week I wanted to explain it with the help of the dissociation context and proper redox potential, but I thought that would become a little harder for people who haven't studied chemistry, because even I studied it in, I think, 4th year of my undergrad. So it's probably a little advanced for all of you. So I'm not discussing the pKa, pKb, and the redox potential, but just to tell you the same thing that I said last time, that there is an electron activity, or the activity of particular compound is related to the pH, or let's say the pH is related to the activity of a certain compound. So we said that in the carbon cycle, and this could be happening in the soil as well. So let's say that in the soil, there's water, and carbon from the atmosphere is diffusing into that water, and it's forming the acid, carbonic acid, which is a weak acid. Now, this is a reversible reaction, and carbon dioxide could diffuse into the water and diffuse back into the atmosphere because it's a reversible reaction. But we also said that when conditions become acidic, they encourage the presence of one species or another. Now, this time we're just talking it with reference to carbonate. So when I said that at a certain pH, one species would dominate and the other wouldn't be dominant. But these reactions where carbon dioxide converts into or diffuses into water and converts into this acid, and that acid then dissociates to give a hydrogen ion, and that then finally gives carbonate, their presence changes the pH. And we just discussed how change in the pH could actually impact the toxicity of these heavy metals who come in a number of isotopes. And I just read in the chat that you want to know more about the leaching. I'll discuss it. I'll see where I can fit it. So just for you to know that when species are present, especially an acid or a base, when a certain reversible reaction happens, and this time it's just with reference to the carbon cycle and its diffusion into water, and how because of the reactions that are happening in that small space with water and carbon dioxide, how does the pH change? And when that pH changes, imagine that in the same atmosphere now, or let's say this is happening in soil or in water, there's also a heavy metal present around it. And this is something that I already told you, that they are more toxic at a certain pH. Now, again, I don't want to scare you off with this. This is just for you to get an idea that at a certain pH, a certain chemical could dominate, right? And a certain valence state could dominate. So let's say lead, one valency would dominate, and that valency could be more toxic than the other. But there's also something interesting that you see here, which is that it will tell you where it's in aqueous form and where it's in solid form. And if you are thinking more in terms of environment and thinking that I have to remove lead from this environment, then you'd of course think of what kind of reactions can take place. Could it just be by changing the pH of the soil or the water body? Or what else do you need to do? Do you need to add something into it? What is more toxic than the other? What is more bioavailable to the plant than the other? And you make your decisions here. So let's say one is more toxic than the other, then you make sure that you stay under pH 8, right? So if it's more basic, you add some acid into it. Or let's say this is more toxic, so you try and add a buffer solution to it to make sure that it doesn't remain more acidic, because you want to get rid of that. And in this, their states could change as well. And especially if you're thinking about environmental remediation, especially if you're thinking about taking it off and not making it bioavailable for the plant, because we just said that the lead that we usually take into our bodies in the form of food that we eat, because very few people are exposed to lead in industries. Not a lot of us are working in such factories or spaces. And to kind of elaborate on that at certain pH, a certain species would dominate. That certain species could be in a bioavailable or non-bioavailable form, could be in a liquid or a solid form. And we have to make a wise decision about making sure that they don't become a part of our food chain. And that decision can be made based on this EH versus pH, or the electron activity versus the pH graph that tells you exactly what's happening at each pH, or exactly what happens when you change the pH. And like I was saying, that if you're thinking of treatment, if you're thinking of getting rid of this, we know it's toxic, we know it's present in the environment naturally or otherwise. Let's say we've introduced it into the environment, and now suddenly we need to badly take this away. The easiest way for us would be to look at this graph and see where is it available for us in a form. So let's say one of this is in a gaseous form, then it would be harder for us to remove it from the environment, because then it goes into the air and disperses. The easiest way for us would be to take it out of the liquid, to precipitate it out, to contain it at one place and take it off. Or maybe as simple as taking all of that water, passing it through a filtration and making sure that that filter, let's say if it's in the nanoscale, doesn't allow for these heavy metals to pass through, and then whatever water we have is clean water. But this graph is, I don't think it's taught enough in the academia relating to environmental sciences. And I do not want to complicate it for you, because it's actually quite complicated chemistry. I just want you to get an idea that these heavy metals have isotopes. Some isotopes are more toxic than the other, and their toxicity could change with the pH. And by changing the pH, we could change it into a form that is less bioavailable, or we could use the same graph to make sure that we are able to remove this toxic metal from the soil or water. Yes, Adil.
Yes, ma'am. I just wanted you to clarify that when we determine that how dangerous an heavy metal is, are we doing it on the basis of the EH or the pH value? Like the more the pH value is more dangerous, or the more the pH value is the more
Yeah, no,
dangerous?
it's varying. When we do the hazard, it's actually on the basis of hazard assessments or toxicity or toxicology studies, which is another side. Like I think just take one or two examples, but here just know that at a certain pH, the forms would change. The only general idea that I want you to get is most of the heavy metals are more toxic at a lower pH in the acidic range. But it is not a rule of thumb. Most of them are toxic there, but not all of them are toxic there. So one form could be more toxic than the other. It's just for you to get an understanding. But the toxicity study has nothing to do with this. That's actually another science where you identify the hazards with the help of what do we call the exposure assessments. So the same things that I was saying in the beginning, that you use a certain chemical and then you expose it. So for example, as you would do it for a drug, right? You would administer the drug into a body and see how much of that drug is effective. And once it increases the concentration, then you see, for example, if it's about killing a viral infection in your body, you administer the drug and you see the lethal dose of it. Now, in that case, you're looking at it in a positive way because it's solving your body crisis. So you're using a drug, you're killing the viruses, you're looking at the lethal dose, you want the lethal dose to be high. That is, you say that at this lethal dose, 90% of the viruses would die, right? And then your body would be able to adapt and find the immunity to fight the remaining 10%. On the other hand, for these toxins, if their concentration increases, then the symptoms that we talked about, that if they are carcinogenic, if they cause skin irritation, if they cause eye irritation, you would see that how when its concentration increases, how does that change it? And it will have to be a separate study for all the species. So it's actually another complicated science, but this particular graph would, once you have done that, and once you know exactly which one is toxic and which one is not, this graph will help you identify how does it change forms in the environment, in the soil or in air, and how can you use that science to solve it here. So for example, and all of this has already been established, so we don't need to do anything right now. We can just go to literature and find out which one's more toxic. So for example, we know chromium 6 is more toxic, so we would try and avoid the chromate section in the graph, which means that we will try and stick to the lower pHs and maybe the hydroxides or those species rather than the chromates. So that's where we would try and stay. So the reactions would be designed such that we don't bring the chromate site into the action and only stay in the site where only hydroxyl ions are present, because we know that they are of chromium 3 species, or are formed with the help of chromium 3 species, and that is less toxic compared to, or non-toxic compared to chromium 6. Does that make it a little bit clear?
Yes, ma'am, it did. Thank you.
Okay. Yeah, I mean, this is another, it's kind of complicated, but it's also, it wouldn't have been fair for you to study heavy metals or the alkalinity and acidity in just like the pH scale and saying 0 to 14 this happens and that happens, unless you understand the complications of it. Like, again, it's not for you to remember exactly everything, but just a basic sense of chromium 6 is more toxic than chromium 4. It's more abundant at a certain pH, and that's why we would avoid those pH. And if it happens in a certain environment, then how do you neutralize it? Rafa, you have a question?
I was gonna ask, ma'am, इसी तरह हम calcium और magnesium को भी remove कर सकते हैं to make hard water to soft water.
Yeah, I mean, कैल्शियम की जनरली, क्योंकि वो मिनरल्स की फॉर्म में होता है, आपके लिए उसकी एक खास कंसंट्रेशन बहुत सही होती है, आपकी बॉडी के लिए सही होती है, आपकी बॉडी और आपके बोन्स और उन सब ग्रोथ के लिए सही होती है. लेकिन जैसे मैंने कहा, एक्सेस ऑफ एवरीथिंग इज बैड. सो इवन इफ दैट इज अबव अ सर्टेन कंसंट्रेशन, that it becomes hard for you to as a water to take it, क्योंकि उसका टेस्ट चेंज होता है, and the way it looks changes. Perhaps it will become more colloidal या जो भी, और उसके फिर आप हर body पे अलग impacts हो सकते हैं. But until a certain concentration, and of course I can't remember it off my head, it is important for you to have these minerals in water because they're essential for your body. पर
एक और चीज,
जी,
तो आप basically pH change करके you're just changing the ionization of the metal, है ना? You're not changing the fact that the metal is removed from it, है ना?
yeah, you're not changing that, but because of that pH change, we are saying that for example, at one particular pH, it would be in a solid form. Now, अब आप अगर कह रहे हो कि ये अब water से, which is, अगर water में soluble होगा तो bioavailable form में होगा, क्योंकि plant उसको ले सकता है अपने लिए. अब वो एक precipitate की form में, एक solid form में आ गया है, और उस solid form को शायद extract करना आसान हो. You know, or it could be the other way around. शायद वो liquid को extract करना आसान हो compared to the precipitates which are in the solid form and have now dispersed in the soil, क्योंकि अब soil जो इतना बड़ा resource है, उससे उसको extract करना मुश्किल हो गया है. Does that help, Rafi?
It does. I've cleared out.
Okay, so now we're going to go back and look at the NEQs. We revised the NEQs for Pakistan. The reason why I wanted to talk about these toxic elements today is because we've already talked about most of the air pollutants before. And instead of introducing you to all of them at once, I decided to introduce them to you bit by bit. So I hope that you already know oxides of carbon, oxides of nitrogen, oxides of sulfur, you know, and all of those basic air pollutants. Today, by giving you a glimpse of the heavy metals and the complications of it in the environment, I hope that it's opened your eyes to how complex it is, right? And that solving it would need much more than just installing one gadget or giving a certain policy or giving a certain standard. You know, giving the standard alone would not be enough. Now, if you quickly look at the standards that we have, they're for municipal and liquid effluents, they're for industrial emissions, they are for ambient air, in general, the air that is around us, and they're also for motor vehicle exhausts. Quick revision for your the same pollutants that we have discussed already a lot of times. And then the standards and what their 24-hour exposure should be and what their annual mean exposure should be. And by 24-hour, they actually mean just 8 hours of exposure. I like the ppm scale better, although the ambient air quality standards are in milligram per meter cube, which is meter cube of air should not contain more than 80 micrograms of sulfur dioxide. I like the ppm scale better, so I've converted some of them for you to make sense of how does that translate into the millionth part of a certain quantity of air. And we already know the toxic impacts. The only new term perhaps in this table was the respirable particulate matter. It's not that different from suspended particulate matter. It just refers to all of that particulate matter that you can inhale, and inhalation could stop at certain points. So let's say PM10 doesn't go past your bronchus, and then PM2.5 doesn't go past your bronchioles, and then finally perhaps PM0.1 could go into your respiratory bronchulus, or finally to your alveolar duct and your blood, or whatever impact that could cause. But I think that was the only new term that was present here. And it's just for you to know, because I think Nadia or someone was asking exactly how much is too much. This is not too much, but this is like the much that we can afford. We cannot perhaps afford more than this. We should stop here, because as soon as it goes past this, it will only complicate our health, our life, and the life of biota overall. So this is just for you to know what the standards are. And I hope that the assignment that I give you helps you understand why it was set to this level. But there's also something which I think I wanted you to explore as well, which is about, air pollutants in general. So if you look at the air pollutants or the limits that Pakistan set, it's only for these classical or popular air pollutants, such as ozone, NOxes, SOxes, particulate matters, etc., as well as maybe, I think, some of these heavy metals, which are put in the inorganic pollutants category. And I think none of these, or maybe just carbon monoxide from the organic pollutants, and that's about it. So most of these pollutants, they don't have a defined limit. And this is just like from a WHO document. Although some of them are present in the industrial effluent or water effluent standards, but in the air standards, most of these are missing, as we just saw, and that's with reference to the ambient air standards that we saw, not the industrial air standards. So I think that's also something that we need to see. And while I was making this table, I realized that we've never really spoken about environmental tobacco smoke, which is one of my favorite topics. Why haven't we spoken about it? Does anyone know what environmental tobacco smoke is? Someone who hasn't spoken in the class yet today. Environmental tobacco smoke, also called secondhand smoke, also called involuntary smoke. Hamza has raised his hand.
Ma'am, like smoke for the cigarettes.
Smoke from the cigarettes, yes.
Yes, like
Or
secondhand, like specifically people who like inhale it.
people.
Somebody who's not smoking but sitting next to the smoke.
Exactly. Yes, Deva, do you want to add something?
Yeah, ma'am, I had the same point. Like, if you're sitting next to someone who's smoking, even though you're not directly smoking that cigarette, the particles will still come and affect your health as well. Maybe not like directly, but like the long run, secondhand smoke.
Yeah, so I think I like cliche. I am very cliche. So this is like a standard cliche image that every environmental sciences lecture has, which is how dangerous the smoke that's coming out from a simple cigarette, a simple, humble, tiny little cigarette is actually, it just look at the sources, and these are probably some of the few of how the same thing that's coming out of the industries or the factories or the batteries is coming out from that simple single cigarette. And people say, and most of the researchers in environmental sciences say, that the passive smoking is more dangerous than active smoking, because whoever's smoking from this end is kind of gets the filtered smoke, right? It passes through that filter and then they inhale it. If you're standing next to your friend and they're smoking, they're giving you all of these bad guys and shortening your life. So the simple way to say it is, don't smoke and don't hang out with people who smoke, because it's not good for your health. But the more logical way to put it is that it's not, obviously not good for your health. And try not to sit next to people who are smoking, and definitely do not allow anyone in your house to smoke indoors. Kick them out or tell them to smoke in the balconies. And Rafa, you should not hang out with your dad and ask them to smoke in the balcony and not inside the house. Okay. And this is really bad, like really, really bad. At least from the researchers that have come out from the environmental sciences area, because I think that there's a lot that we studied in this on how it impacts. Smoking in general is worst, but passive smoking is said to be more dangerous, especially for people who already have weaker tendency to absorb onto these pollutants. And we said that was the quality for the ambient air. For the industrial air, the limits would be slightly higher. They are the same. This time, alongside those traditional classic air quality pollutants that we studied in the atmosphere, the toxic metals that we just studied in this lecture are also present, because, as we said, one of their major sources of emissions is the fossil fuel burning, or the industrial liquid solid fossil fuel burning. But there's also something that you would see here, which is called limit for smoke. And this is the scale that's used to describe the smoke. Pakistan's limit is this one, Ringelmann 2, which means that the filter or whatever you're using to see how much smoke is passing through should have at least this much visibility, or clear visibility. And our air is probably somewhere here. So I don't know what the current conditions of the air around us are, but that's the limit. And if it goes past that limit, it's breaching the standards. So the EPA should go and, I don't know, fine the industry and stop them from functioning, or penalize them and make sure that they've installed some form of gadgets to clean the air. We'll try and study this. This is like sulfur dioxide and nitrogen dioxide standards for fossil fuel burning in the next lecture, because we'll try to look at the renewable and non-renewable resources of energy day after tomorrow. But this is, in the last lecture, we definitely discussed COD, BOD, TDS, and TSS. Now, what I've done is stolen a graph from a paper, and this basically gives you the values for pH and those for parameters of different industries as well as domestic sewage. Can anyone, just by looking at this, guess exactly what is going on, or tell me what's going on? And it can clearly be a guess, because even I'm going to guess by looking at it. So for example, I can tell you that the domestic sewage has lower biological oxygen demand and chemical oxygen demand compared to most of the industrial activities. Actually, a standard municipal wastewater from developing countries has a COD somewhere around 300 to 400 parts per million or milligrams per liter, but 500 is also fine. So let's say that this is the COD for domestic waste. What can you observe? No one's raising their hands. I observed something when I was looking at it. I didn't realize how high the COD and BOD for dairy industry is. I always thought that it was the highest for textile and pulp and those kinds of industries. I knew that the TSS would be low, but even I think the TSS is quite high for the dairy industries. But if you look at it, and then of course I had to look up why that is, and that's because of the lactose and a lot of other components that are present in dairy, and not just the milk, but the dairy products. When you're creating cheese, you're kind of concentrating it, leaving it for a lot of time, and automatically the organic content is increasing, and that's why the BOD and COD is increasing. And why is that important? Because the higher the BOD, the more the strength of the wastewater, and the more time more chemicals would be required to either take those chemicals away, or more time or more microorganisms would be required to degrade that chemical. what's the question? On what conditions do the COD and BOD levels depend? They depend. We discussed this last time, guys. Come on. Okay. So basically, biological oxygen demand would be the demand of microorganisms for oxygen to degrade biodegradable pollutants or biodegradable nutrients. And biodegradable mostly is organic. And organic mostly is compounds that contain carbon and, let's say, hydrogen and other elements. So it generally comes in the form of organic pollutants that are biodegradable and contain carbon, and could just be like sugar and other ethanol and other nutrients that are coming in the form of waste, or just like wood, lignin, leaves, and other organic matter that's present naturally. Chemical, on the other hand, is not just the biodegradable components or the organic components, but also the inorganic components. So the kind of chemicals that cannot be degraded, and this is more relevant for wastewater treatment, the kind of chemicals that would not be degraded by bacteria or other forms of microorganisms or life, and would need other interventions to be taken care of. So it could be with the help of adding more chemicals, changing the pHs, coagulating, flocculating it, adding something to make sure they precipitate out or something along those lines. And it could be so all the oxygen that's needed for all of those is called chemical oxygen demand, which is a combination of BOD and the non-biodegradable carbon that is present, or elements that are present. And just because we're at the topic, I thought we should also look at the raw wastewater values for TSS, volatile, nitrogen, which could come in the form of nitrate, nitrite, ammonium, total Jadal nitrogen, total nitrogen. So these are like the parameters that are generally reported for wastewater treatment, just for you to have a look at. I don't want you to look at a paper relating to wastewater and think, what is this? But we will discuss that. So now I have quick questions. How much time do we have? Oof, very little time. I have a quick question, and maybe I can just ask one of them to you. So fluoride in the toothpaste, yes or no, and why? There are a lot of myths and a lot of realities. For example, when I was growing up, we were given the impression that iodine is so important in the salt. And suddenly iodine's been taken away from the salt. And there's not as much emphasis as there was when I was growing up. At least not, like we used to see a lot of advertisements on TV that said, iodized salt, avoid thyroid glands, blah, blah, blah. But the same is not being said now, because they know that a lot of iodine also can be problematic. And then how do you define that only the permissible amounts of iodines being taken by the plant? So SDS in shampoo, no, yes. And even SLS, like of course I've used shampoo that used to contain SDS. Now it's been phased out and sodium lauryl sulfate is introduced, but even that is toxic to a certain extent. No to fluoride in the toothpaste, guys. Those who said yes, no, because I think it's a myth. And the myth is that somehow fluoride is going to stop to decay, and it's found naturally, which it's not. Most of the fluoride is in the form of fluorides, and it's calcium fluoride, and the toothpastes generally contain sodium fluoride, which actually then eventually realized that there was a lot of negative impacts of excess fluoride, and fluoride ingestion is toxic to body. And that's why the same myth has been broken, and you don't see it in the advertisements anymore. But behold, maybe like 15 years from now, all the things that you're doing today would also turn out to be carcinogenic, and you'll be telling your future generations not to use them. Okay, so the next example is of, this is basically based on a news that I was reading yesterday, which said that the coral reefs, at least 50% of them, have diminished under the ocean. And they are very important biomes for all forms of life under the ocean. And another graph which standing next to it will tell you that the IUCN Red List, which is a list of the endangered species, will show you that the corals are doing really poorly. And you know why all of this is happening? It's happening because there's a rise in temperature, and these guys are not as good at dealing with the rise in temperature as many other higher forms of life. Now, let's go back to municipal and liquid industrial effluents. And again, I think we discussed this, we touched upon this last time. I just put it here in case you have any questions. There are limits. The limits mean that you cannot, industries cannot, households cannot, municipalities cannot throw wastewater outside into the stream. So for example, if you just look at this, it says that the chemical oxygen demand that you throw into inland water should be 150. I am 100% sure that the Nala that's outside of Lums, which is an inland water body now, actually has much higher COD than 150 because none of it is being treated. We just read that the municipal waste has how much? Up to 500 ppm or milligrams per liter of COD. Now, the standards say that any wastewater that's going from our house to an inland water or to a stream or to a river should have 150 milligrams per liter, because we are not treating it unless there's a lot of water coming in from a swimming pool or rain, and that's diluting it. There's no way for it to have come down to 150. So I'm 100% sure that it's more than that. So that's like just for you to get an idea of what that means. Right, and noise pollution. This is quite simple. I think I want you to talk about it. Yeah, Lums cannot do anything about the Nala. The Nala is our favorite. The Nala is our favorite topic at the Center for Water Informatics and Technology with Lums SSE. But there's nothing we can do because there's so many stakeholders that are involved in it, and it originates at a certain point, ends at a certain point. Even if Lums does anything outside of Lums, whether it's covering it, treating it, lining it, aerating it, because providing more oxygen would reduce the smell and maybe encourage microorganisms to degrade it. It wouldn't solve the problem because the source is still on and people are still throwing from the DHAs and from the paragons, all the wastewater is still coming in. So there's very little Lums can do unless all of those stakeholders come on board and say, let's treat it at least to bring it down to 150 COD in milligrams per liter before we throw it into this one. In any case, I think it's not a rainwater stream. It is definitely a wastewater stream, and it should be covered and lined properly because it contains microorganisms that are dangerous for our health and chemicals that are dangerous for our health. So what is noise pollution? So Pakistan's standard for noise pollution is 85 dBA, which is decibels. And it falls in this area, which means that a busy city with traffic is our limit for noise. So if you have a neighbor who's trying gunshots all the time, or fireworks, or if you live next to service lane like I do, and they play music at such a high volume all night long, then you definitely need to call somebody and complain about them. Because legally, they should be staying under 85 dBA. All right, we don't have time for this, but I hope that you can do it at home. Just grab any chemical that's next to you, whether it's a perfume or a glass cleaner or anything, and go and look up the chemicals. Every chemical has a material safety data sheet or MSDS that is present online, and it tells you how toxic that chemical is. So just to be sure what you're using it wisely, make sure that you are looking at it. So quickly, because how much time do we have? We have 5 minutes, so we have a lot of time. Now, in all of this discussion, you must have realized, as I discussed in the beginning, that there are so many chemicals present all around us. And we as a country have only defined the limits for a certain sum. What do we know about the air quality? How much is the air quality being monitored apart from these classical air pollutants? What are the background conditions for all of those heavy metals that we just discussed about in the air, in the water, because we certainly know of areas that contain arsenic because it's present in the bedrocks or in the aquifers from the sediments that are present there. What about food? Because if we are saying that most of them are being ingested by food, what are our food testing standards? How do we have something of our own? Do we look at FDA or and their values? And if we do that, who is monitoring it? Who is testing our food for the toxic elements that it contains? For example, a friend of mine in the undergrad was looking at the adsorption of these pollutants, these vehicular exhausts on the fruits that are present by the roadsides. And she showed from her research that long-term exposure could cause more adsorption onto the skin. But not every fruit can just retain it into the skin. It can also absorb it in. And if you're not washing it properly, if you're eating it directly, we get exposed to that chemical. So this brings me to your assignment number 2, which is that you have to choose 10 parameters of your choice from the gaseous or industrial and liquid effluents. And then you have to compare that standard with a standard from any developing country. Could be, I will appreciate if you go to compare it with Europe or maybe Canada, countries that are more aware of the environment and more careful towards the steps that they take toward restoring it. And then also spot the differences, the gaps. How are their standards different? How are they defined differently? And it's just 10 parameters, so it's easy. I'll put it on the LMS. And I had started a poll for a date for midterm. And if you have participated in the poll, I would be very, very grateful to you. And I think with that, I can take your questions and quickly look at the poll. Oh, none of you. Oh, okay, most of you have voted. So most of you say that it should be on the 2nd of November. But 36% say that it should be. Okay, now the other thing that you need to know is if it is on the 2nd of November, throughout that week, you'll have to give your Viva. And I want it to be after your midterm, of course, because then you would have prepared better for it. So let's say 2nd November is the locked date for the midterm, because a lot of you had queries on when the midterm would happen. Guys, official announcement, it is on the 2nd of November. And if you don't have any other comments, I am leaving you 1 minute early. Adil.
Yes, ma'am. Can you please guide us about the questions format and the number of questions we'll be attempting in the midterm? And in what detail should we learn about the like the
So
facts?
I was just telling before, like when the lecture started, I was just saying that I know that memorizing things cannot last longer. So I'm not a big fan of memorizing things, but I also not like it when people take academia and academic knowledge very casually and can just sit on their couch and talk about it. So as long as it's you don't have to memorize everything, but do go through the slides, make sure you understand everything. Very often in the slides, I did not expand the terms. I left some room. I did not explain certain things because I wanted you to ask questions in the class, or sometimes I wanted to ask you what that meant. Or sometimes I wanted you to, while you were reading it, go back and see in your notes what that meant, because I said the expanded version, but in the slides I put, for example, PB for lead. And make sure you know those things, right? And make sure you kind of understand what we've been trying to establish of the different things in these different spheres, but then how these spheres are interconnected. Pollution in general, or for example, in the case of pH and toxicity of heavy metals, we don't think about environment like that. Generally, we just say acidic, basic, full stop. pH 7, pH 14, pH 11, or whatever. But think beyond that. And once I decide on the structure of the exam, I will let you know, which would probably be in the next week. There will be same questions, questions for you to think about, something similar that I've given you for the assignment. Maybe I'll present something and ask you to think about it and then write the exam. I'll try and keep it short because your Viva will follow up the exam. That's where I could test some of your learning skills. But please make sure you've read them well, and whatever you write it well, because a half-hearted answer is a no.
So
Yeah.
the questions would be more. So the questions would be more like the quiz we had. Like they would be more analytical rather than just knowledge based.
Yeah. And could I give you a question on converting micrograms per meter cube to parts per million? I could, but that's if I've shared the formula with you already. It wouldn't fall from the sky. I'll provide you the basis for it. That is whatever knowledge is required to interpret it. It would be there.
Okay, ma'am. Thank you.
Yes, Atka.